All right, let's look at 1.5 divided by 3/4, and the first thing that I want you to think about is, can we do this using the partitive technique or the subtractive or measurement technique? Can we take this and divide it up onto that many plates for partitive, or can we repeatedly subtract that much from the original amount? Think about that. Since we're not dividing by a whole number, we cannot use the partitive division technique. We're going to need to use the measurement or subtractive technique. The way that I see this the best actually is having a cup and a half of milk, and how many 3/4 cup servings can you make. But I can't record the measuring cups and stuff well here. Maybe I'll do that in another video. So regardless, you've got 1.5, and you need to decide how many 3/4 cups you can remove, or 3/4 pieces you can remove from that. So how many of this size piece can we remove from that? But since this is not in quarters, like you can't just break that piece right there. So we're going to have to do some exchanging with the base blocks, and I'll show you how to draw the things later. If we take, here's our 1.5. I always like to have the holes there, so you see there's our 1.5. If we present it in a way that we can take out the quarters, we'll replace the 1 with 4/4, and we'll replace the half with 2/4. Boom. So we still have 1.5, and we're being asked how many 3/4 size pieces can we take away from this. So we can take away 1 3/4 piece here. Okay, and then here's another 3/4 here. So we'll end up with 2 3/4 that we can take away from 1.5. And let me show you a couple different ways to do that. So with drawings, so far I've drawn our 1.5. And I'm trying to take out as many 3/4 size pieces as I can. So I'm going to go ahead and divide each of these so that you can see quarters. I'll do this one this way, and this one this way. Okay, that doesn't even matter because we don't even have that. And then from there I'll go ahead and do the lovely Charmaine swoops and say there's 1 3/4 we can take away, and here's another 3/4 we can take away. 1, 2. We can take 2 3/4 away from 1.5. Another way that I would love you all to kind of think about this problem is with money. $1, $1, right? Here's $1 and 50 cents. You can look at 50 cents as 2/4. How many 3/4 can you take away from that? If we had actual money here, the dollar could be exchanged for 4/4, and then we'd still have our 2/4. And how many 3/4 can we take away from that? Well, here you go. 3/4 once, 3/4 twice. So that might just confuse you all. I'm not sure. And then I guess I should show how to do it by hand as well, or by arithmetic means. So 1.5 divided by 3/4. In order to do this, you need to first convert this into an improper fraction. So 1 is 2/2, and 1/2 is 1/2. So 2/2 plus 1/2 divided by 3/4. 3/2 divided by 3/4. Okay, I am going to just use the keep change flip on this. That's discussed in a couple other videos why it works. So 3/2 times 4/3. You multiply across. There's 2 ways to deal with it. I guess what I'd like to do is show you that it's 3 times 4 over 2 times 3, and that the 3 and the 3 cancel out because 3/3 is 1, and you get 4/2, which you can write as 2 times 2 over 2, and those 2's cancel, and then you get your lovely 2 that you got from the picture. But I wanted to show you a couple different visual representations of it, and we'll work on word problems on the discussion board as well.